Alright, so now we're going to hit on a little bit of review of the unit circle. This was a huge part of the year. I know there's only 4 problems shown here, but my goodness, make sure you know how to do this and anything in the notes that goes with this, okay? So first we're going to do conversions. If you are given a radian and you have to convert to degrees, all you have to do is multiply by 180 over pi. And then you're just doing, you're just simplifying. These pi's are going to cancel, and so it's 180 over 11, and if that reduces, you can reduce it, and if it doesn't, you do not. So actually, I believe we are done. Now, if it is not a fraction answer, that means that they're allowing you to have a calculator. So you could just type in 180 divided by divided by 11 and get 16.36. So you might also have a decimal like that. There you go. All right, what is 56 degrees in radians? So for going the other way, you just flip this, gang. So it's 56 times the pi on top. And this is one that usually you do not get a calculator for. You want to just reduce the fraction and then leave the pi as it is. So I'm trying to think of something that goes into 56. I think 4 goes into both. So 4 goes into the top 14 times, and 4 goes into the bottom 45 times, and then there she is. That's all we have. So that would be your answer to that. Number 7, find a negative and a positive coterminal angle for both of these. So let's do the negative 110 first. If you are given degrees, remember that coterminal angles, all that means is revolutions. Okay, so imagine going around the circle forward and backwards, and so your formula is that you just take the angle and you add and you subtract 360. So that's what I'm going to do. I'm going to take negative 110, and when I add 360, I'm going to get 250, and there's my positive one. And if I take negative 110 and subtract 360, I'm going to get my negative 1, and I'm done. 3 pi over 7, same story, but different number here. This is the angle given. You don't want to add 360 because this is radians, but a full circle in radians is how much? 2 pi. So we're just going to get a common denominator here. This is really over 1. So let me turn that into a 7, which turns the top into a 14. And then I'm doing 3 plus 14 over 7, so 17 pi over 7, and then I'm doing 3 minus 14 over 7. So my 7s look terrible, but that's a 7, so those are all 7s. Okay, so there's my 2 answers, positive and negative for that one. All right, now the fun stuff. Yes, you still have to know your unit circle, so hopefully everybody does. The cosine is the x value at pi over 3, and hopefully we know that that's a 1/2. The cotangent of pi over 2. Now cotangent you have to do a little bit of work on because the cotangent means the x over the y. So at pi over 2, I know that the x value is 0 and the y value is 1. So 0 over 1 is 0. Now if that had been flip-flopped, guys, if this had been the tangent, maybe I did that wrong. No, I did that right. If this had been the tangent of pi over 2 and you were doing y over x, and so you had 1 over 0, you would have to put undefined. So just kind of be careful there. All right, sine of negative 5 pi over 6. Well, the first thing I would do is think about the circle, and this is positive 5 pi over 6 over here. So negative 5 pi over 6 means you go the other way. So this is really the same thing as 7 pi over 6. So if I'm down here, the sign would be the y value there, which is a negative 1/2. The secant of negative 135, so same thing. First I want to actually draw where this is, okay? Positive 135 is here, so negative 135 is there. Okay, now if I'm down there, there it is. If I'm actually down there, Now I know that this point is negative root 2 over 2 comma root 2. So, and we need the secant. Now what does secant mean? Secant is 1 over the, secant goes with cosine, so it's the x. So if I take this and put it under 1, now I just have to clean it up, okay? So it's going to be negative 2 over root 2. And when you rationalize this, it looks like it's going to be a negative root 2. There we go. And that's how you'll do that. All right, the last one is actually graphing and then telling all about the graph. So we are going to sketch this and then do domain, range, period, amplitude. So to sketch it, let's first, I'm a big fan of drawing the parent first. So cosine is the one that starts up here. There's 2 pi, and then it continues. Okay, so a negative is going to reflect it, and a 2 is going to change the amplitude. So right off the bat, I'm going to go ahead and write that there's an amplitude change. So I'm going to flip this, and now instead of it going to 1 and negative 1, it's actually going to stretch and go from 2 to like negative 2 here. So if I'm trying to flip and stretch at the same time. Okay, so that is me handling the negative 2. All right. Now we have a 3 right in front of the x. That's actually going to change the period. Now the way that it works is it doesn't mean that the period is 3. You're supposed to take that number and put it under 2 pi. So the period is now 2 pi over 3. So that means that this graph is going to shrink, and you're going to see all of this before you ever get here to 2 pi over 3. Now, to make things easier, I like to just change my scale. So I'm like, oh, it's going to look like that, but now it stops at 2 pi over 3. So I would just change my scale. This is now 2 pi over 3. Halfway would be pi over 3, and that's how I would label my picture. Now the last thing is the +1 at the back. And what is that going to do? Well, the +1 is a vertical shift. So it's basically just going to move all of this up 1 unit. So I'll take this point, move it up 1. This moves up 1. That moves up 1. Everybody's moving up 1. Isn't this exciting? Oops, that was there, so it's there. Okay, so it's going to be like, whee. Alright, so the red one is my final graph, and I've already done period and amplitude as I went. Domain is just going to be all real numbers because you should really make this keep going. And then range is going to be, no, hold on gang. Okay, that was scary for a minute. So now that we're back, I don't know what I was writing. I think we already did domain as all real numbers. Yeah, and I had even la 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 la. Okay, range is going to be the bottom to the top. So now this is at -1 on the bottom, and it goes all the way up to 3. So I just look at my picture for that. But anyways, if you've got a calculator, man, these are a lot easier. I'm not sure if you're going to have one. If you are going to have a calculator, please remember that you need to be in radians. Otherwise, you're going to see a straight line. You still need to know how to do these without a calculator, just in case. But in case you get one on the test, you can definitely type it in to double check. All right, that's it for that part. The next video will be identities.